what sustainable design is and ways that we can really kind of take this this knowledge and apply it to your own homes and to the buildings we live in.
One thing solved.
Okay, stereo. Okay. What is sustainable design? Right? We're here to. You're all here because you're interested in sustainable design. You have a lot of desire to incorporate it into your structures. But what most people think it is what, solar panels and low-flow toilets and some crazy-looking light bulbs. And it is those things. Let's see, podium mic. Let's see. Auxiliary might be more technical issues.
That's okay. That should.
Everybody here? Awesome. Thank you, tech support. And it is those things. It is solar panels. It is low-flow toilets. These are all important things, but that's not really the meat of what sustainable design is all about. Sustainable design is, and before we can really talk about sustainable design, let's talk about what regular design is. What's conventional building, right? Typically buildings are built, and there's a agreed upon set of rules that we build our buildings by, and we call those building codes. The problem with codes is that anything less than building to code would be illegal, right? So when someone say a building, it's Title 24 compliant, what does that mean? That means that you're not breaking the law. You need to build to Title 24. You need to build a code. That's the minimum that we need to build to. So okay, it's not really that easy, and those buildings are horrible. Code is not a great building, and we recognize that. So we recognize we needed something better. And they come up with what's known as high-performance design. And high-performance design is LEED and some of the other building metrics that are trying to incorporate new things, new technologies to make buildings more efficient, more in tune with their water usage and their electrical uses. So it's design that has a high efficiency and reduced impact to building structure operations and site activities. Now the problem with that is that a lot of times it's focused on actual kind of technological fixes, new water systems, new things, new gadgets, and it makes buildings more expensive. Sustainable design shouldn't be more expensive. It should be something that is just an obvious way to build, a common sense approach that we don't have to have such great impact. So, there's a little bit better we can do with that, right? So let's look at sustainable design. Well, sustainable design promotes a continual improvement towards a whole and healthy integration of human activities with natural systems, right? That sounds great. Now, the problem with just sustainable design is that we're just sustaining the status quo, right? We're just trying to reach a level where we're not doing any harm. And our buildings don't have an impact. So we have these net zero buildings, and everyone wants net zero. Can't we do better than net zero? Can't we, as Josiah showed some of the inspirational things, can't we have buildings that actually give back to their environment? World famous architect Bill McDonough, he's a big green guru. He says sustainable design is essentially 100% less bad. Okay, that's a great way of looking at it. Another famous architect, Bill Reed, he says at its best, green building is nothing but a band-aid. It's just a stopgap on a way towards destruction. So that's not really positive. However, Bill Reed is a big proponent of integrated design. So instead of just the traditional design approach where you have an architect and a client get together, talk about the program, figure out what the needs are, they do some designs, a structural engineer comes along, figures out how to build it, you bid it out to a few different contractors, the contractors figure out how much it's going to cost. No one really goes to the site yet, the client and the architect have been there, but who knows the contractor ever goes or the structural engineers that have been there. Doesn't matter, it's just a building, just a bunch of numbers. And they, finally the thing gets built. Okay, that's a completely disjointed way to build. There's a better way to build. That system is basically a degenerating system. It's a system where no one's really in communication with the site and ecosystem as a whole. It's a fragmented approach towards building and towards understanding our buildings and their relationship to the environment, to the site that they live on. There's better ways to do it. So he came up with this chart, and basically this degenerating system is conventional building. That's the way that we build. You have a kind of linear process that you build buildings in, and there's mistakes that happen, and they're expensive to fix along the way. A better way is this, kind of high performance design, is LEED. Well, LEED gives you a set of ways, a set of goals that you want to reach. So it tells you kind of where you want to go, but it doesn't tell you how to get there. So it doesn't really show you the way. It just shows you things that you want to do, or things that you want to achieve, but it doesn't tell you how to achieve those things. So, and again, it focuses on these technologies. It takes a lot of energy to, one, both emotional energy and financial energy and actual energy to do these degenerating systems. And the more technology you put into it, yeah, it can get a little bit better. You can make it a little nicer. But again, we're all working towards this neutral, 100% less bad, sustainable design goal. Now, if you focus on what can you provide, can you make a net positive building? Well, then that's even better. You can make a building that's restorative. It's going to actually add to the site, filter the gray water, filter the sewage. It's going to actually, humans are going to do things to the natural environment to make it better along the way. But a real goal is this regenerative approach, where humans are intentionally participating as nature, not something that is separate than nature. Now you're living on the earth, nature's there, and you're here and there, and it's there, and the site's there, the building's here, and the site's there. It should be all integrated into one. You should view your building, view your lives as part of the organic ecosystem that we all exist in. And that's really the goal of sustainable design. It's not just, can we be, get back to 1990 levels. It's, can we really be part of this planet? We do not exist separate from the planet. We are co-creators of our experience here. So, basically what we talk about when we talk about green building are three things: materials and energy efficiency, healthy interiors and indoor air quality, and the durability of the building. And when I say green building, I'm kind of taking that term, which is really generally used as a not as rigid term, and kind of replacing it for this larger rigid context, or larger expansive context that I'd like to express it as. But these three things are really the meat of what green building is trying to get to: efficiency, indoor air quality, and durability. So, why is it so popular right now? Let's try to talk about these three things and what we can do and how these things, bring to light. Why is green building important right now? Well, energy is obviously an important thing in all of our lives. The price of oil is on an upward trend. Has been ever since we found oil. It gets more and more expensive as there's less and less of it. That's not really the main reason, because we're running out of it to do it, but we're out of oil, and it's only going to get more and more expensive. All of our other energy, our energy consumption is really based in unsustainable ways, materials. I probably don't need to tell any of you this, that our petroleum, natural gas, and coal and nuclear are all completely unsustainable. As you see, we haven't really changed our hydroelectric and wood use, but our energy use is skyrocketing, and our population is growing, and it's only going to keep on needing more. And I know you're going to say, well, hey, we got solar panels. This building has enough solar panels to power 30% of all their usage here. Okay, you got solar panels. Well, is that going to do it? Well, no, not really, because look at this chart. This is our electricity that we get from renewables. 2%, is renewable power. Okay, some people say it's more than that because hydroelectric, and they aren't really building new dams, but even 9% say is renewable energy. Well, let's take a little closer look at what that renewable is and where solar panels fit in. There you go. Wind turbines, less than 1%. Geothermal, biomass, which is wood. Solar photovoltaics, 0%. So all the solar panels you see and all the roofs and all the things everywhere, yes, they're doing great. They're not even a blip. And it's not just the government money that is not flowing towards solar initiatives and everything else. It's just not where it needs to be. We have a lot of potential, and we need to really take this seriously to understand our place here. We can't keep doing it the way that we've been doing it. Again, you guys are all here in the room, so I'm assuming you know that. Next reason is health. Obviously, our buildings are full of toxic chemicals. But healthy and indoor air quality is important because we spend 90% of our time indoors. And indoor pollutants are 2 to 5 to sometimes 100 times higher than outdoor levels. 15% of Americans are allergic to their own homes. That's crazy. 40% of children have some sort of respiratory disease. It's a wild concoction of chemical soup that we've encased in these little buildings, and we call that a home. You know, a home should be a place that you know and love and have memories of, and not something that's going to make you continually sick. You know, so where do these pollutants come from? Well, from all sorts of building materials, from asbestos and formaldehyde in our you know, fireproofing, waterproofing, insulation, mold and mildew, just water leaks, you know, bad plumbing, bad detailing, fire retardants in our furniture, in our you know, formaldehyde in our cabinets, tons of different things throughout, and all these are opportunities to first green your own house, to not have all these things floating around, these toxins floating around. You know, it's almost as if that, you know, a house should come with some sort of warning label on the side of it, so you know what's going to go on, you know, into your own house. You know, so, you know, what's wrong besides all that? What's wrong with conventional building? That should be enough. But the biggest problem with conventional building, and the reason why I got involved in architecture at all, is waste. You know, the average U.S. home has almost 14,000 board feet of lumber, 11,500 square feet of sheeting, 17 tons of concrete in that house, and you're looking at a, you know, pretty modest 2,300 square foot home, which is small by today's standards. It's average, I guess. New construction, though, if you look at the waste involved, new construction of a home averages 3.9 pounds of construction demolition waste per square foot. So if you just multiply that out by the square footage of the average house, you're looking at 4.5 tons of waste for every house built. You know, that is a huge opportunity to make things better. You know, and if you demo an existing house and build a new house on top of it, you're looking at 155 pounds of waste on top of that number. You know, if you multiply that out, that's over 180 tons of waste. So you're looking at 185 tons of waste to demo a house and build a new one. That's like as much as the house weighs. It's a ridiculous mess that we've created, and you know, I'm going to try to show you some ways to mitigate that. One way is through a better framing, efficient framing. If you're building a house, if you have the opportunity to do a remodel or do an addition or change some walls out, that's great. Typically, buildings are built by 2x4 studs. This is wood construction. Homes mostly is wood construction. 2x4 studs, 16 inches on center. You can get the same structural characteristics using 2x6 studs placing on 24 inches on center. In that, you get a deeper stud bed, basically, in your walls. So you can fit more insulation in there. You have less spaces that are non-insulated. Where the wood touches the outside of the house, you're looking at an uninsulated space, you know, a thermal bridge into the house that causes, you know, you not to have an insulated space there. So if you have less wood on that thing, you have a deeper space for insulation. You have you save 30% of the wood, and you have added insulation. You know, and not only do you save that wood and the insulation, you have reduced labor and construction time. It makes things easier and faster to build. You save, obviously, the resources. You reduce waste of all kinds of cutting things to fit. You reduce drywall cracking. Your sheet goods, your 4x8 sheets now fit in that 24-inch module. These are kind of common sense things that some builders are implementing. Most are not. Most are not. It's just because it's just done that way, and that's just the way it's done. But these are not brand new ideas. This is just kind of basic green building. And it's not really doing much different. It's just changing the thickness of the wood stud that you're using, and you can automatically save 30%. Another way is in framing. You know, again, these are kind of construction details, or at least, you know, concepts. But the standard corner is here. You know, you put a bunch of wood in the corner of the house, and then you have no insulation in that corner. You run the insulation up to it, and then you have your corner boards at the top there. And the problem with that is that corners of buildings is where the wind kind of hits your house and it whips around, has a little vortex, pulls heat right out of your building, pulls your heat or cool, whatever, your temperature difference out of the building through that corner. There's no insulation in that corner. Same thing at T-wall intersections. You have no insulation in the void. The reason why they're framing it like that is so your drywall on the inside will have something to nail to. there's better ways. I mean, this is known as the bottom here, is advanced framing, but everyone's calling it California framing because this is what the way we're trying to do it in California. You know, put some insulation there, insulate your corners, use drywall clips so you don't have these voids in your envelope, your building envelope, that are going to just suck energy out of your building. You know, and doing this, again, you save 30% more insulation just by changing the way that you're framing. You're saving wood and you're saving energy. It's a no-brainer. A lot of times, I don't even have to mention this to my clients. The builders will save 30%. Good for them. Great. The same thing with interior walls. You can use drywall clips. You can save so much wood with just efficient framing techniques. And again, this takes education in the field. This takes teaching contractors and framing crews better ways to build. You know, there was a time that it was a noble field to be a builder, to be someone who was educated and you had a role in society to be a builder. Now, unfortunately, construction crews now come from the kind of the lowest uneducated rung, and it's a shame. It should not be, and people get stuck in their ways. But this is an obvious transition. Again, another thing is what kind of wood you use. Certifications matter on wood. There's a lot of different certifications out there. They're there to confuse you. The only one that should be valid right now is FSC, the Forest Stewardship Council. They're third-party verified continuous chain of custody of that wood from sustainably managed forests, which essentially means that the forest is kept intact, the ecosystem is kept intact. They pull specific trees out of that forest and leave the forest intact. This is SFI and FSC. This kind of shows you right away. SFI is the other kind of big one. The lands kind of butt up to each other, but FSC is trying to make sure that there's continuity in that ecosystem. Whereas SFI, it's cheaper. That's why wood is cheaper. It's cheaper just to clear cut that. You have the roads built and tear it out. It'll grow back. It's renewable. It might take 40 years, but whatever. PEFC is getting a lot of traction. People think that's they don't really see it as often, so they think maybe that's an okay one. That's basically the European version of SFI. Another reason why green building is important right now and why these changes need to happen is that simply that we're smarter. This is in my job now. Again, I'm a forensic architect. I see this all day long. You pull the siding off a building. This window is held in with duct tape, and there are staples all through the tie bed. I picked one picture out of a million that I have in my office. This is typical. Once you put the siding up, no one sees what's happening. This is a hotel on the coast in Mendocino. Of course the windows leak right away. So it's amazing when people get by because they think, oh, no one's going to see it. But this is absolutely typical of the way buildings are built. Keeps me totally busy. I would love to be designing beautiful houses, and I've done that for 10 years, but right now, in this down economy, I have endless stream of work because there are crappy buildings everywhere. But we know better ways to build. We know ways to mitigate water. We know ways to mitigate vapor and to better insulate our stud bays and to better insulate our buildings, to retrofit our buildings. These are not really hard things to find. A lot of these details are available for free on the internet. Easy to find. Builders should take some better education. Figure out how water moves and try to get it out of your building. It's a basic concept of shelter. We are, as architects, as designers, and as homeowners, our idea of shelter is just to keep the water out, keep us safe and warm. It shouldn't be that hard. For some reason, people just don't think about how water flows. It flows downhill. One simple way, if you have the opportunity to do some work on the outside of a house, a rain screen. A rain screen wall is a very simple concept. Basically, it is removing the siding, the exterior siding of your house, giving it an air gap so that you have basically a place for the water to dry out before it touches your building. Very simply, just by putting up these furring strips, which are pieces of wood, and nailing to that and letting your waterproof plane sit behind it. So any water that gets behind it will dry out, and it creates an air differential, so air kind of flows through your building, creating your extra layer of insulation, allowing your insulation to work better, and water not to get in. This can be done as a retrofit. It doesn't have to be done in new construction. If you're adding insulation to the outside of your house, you can always add these furring strips to the insulation and move your siding out a couple inches. It changes everything, makes your house so much more stable. What does this look like? Let me see, I got a building. This is actually the building that Josiah and Drew Merritt and I worked on years ago. These are actually some early photos when it was under construction, as it was finishing construction. But this is a rain screen siding. We used reclaimed redwood siding on the building and a fiber cement. And so this wood had already been reused. This is already from another barn that we had sourced this wood, and you can see the old paint that was still from the old barn on there. And one of the benefits of doing a rain screen, and especially one like this, was that this will be totally. This is untreated wood. There's no sealants at all on this redwood. Redwood will last a long time. It's great against UV. It'll have a nice gray tone as it kind of ages, and that gray tone, that silver tone, will last 40, 50 years. Okay, and when it starts really weathering really bad, and the clients are like, it needs to get changed, just unscrew it, flip it over, put it back on. And you extended the life of that building for that's 80, 100-year siding on it, easily. Drew was just telling me, met with the clients recently, and they love this house, and they said the best part about it doesn't leak at all. And it's really from the rain screen. I mean, it's an easy technique. Okay, so I know you guys are all here for some real practical knowledge. You want to find out what you can do to your house. So I tried to condense a few gems. Some of these you might know, some of you not know. But number one, try to get a home energy audit. There are basically free audits that governments and energy companies will provide. They'll send out to your house. If not, there are private companies will do a full home energy audit. These are thermal cameras, images that show you what insulation looks like when the heat's not getting out, and you can see as it gets darker, you can see the stud bays there on the blue. When it's an uninsulated wall, the heat is just going right out your wall. You're just paying to insulate the wall, paying to heat the wall. You can, if you have the opportunity to open up a wall and insulate it, great. But I know we don't always have that opportunity. This is, in our company, we do a lot of water mitigation. So these thermal cameras also show you water. They show you where the water is leaking. This is a roof leak that you otherwise wouldn't see. Here's the full thermal camera image. You can see that it's kind of darker and colder. It means the water is kind of growing on the backside of that drywall. You can zero in and actually see where the water is. And again, same thing on this foot. There's water leaking underneath those vinyl tiles there. You would otherwise never see. But we have the technology now. There's no technological, nothing stopping us from using the tools that we have to really fix the buildings we have right now. A big thing is insulate your spaces. I think obviously insulating between your garage and your attic. A lot of times that space between, if you have an attached garage in your house, the space at the top there is kind of open to the attic or not sealed well to the attic. That lets in unconditioned space into your living area. And also lets in all the chemicals in your garage and the stuff coming out of your car, just floating into your attic. These are things that a homeowner can do in a weekend and better seal. You can obviously have people in there to fix it nicer. But making sure that your space that you live in is actually a conditioned space. It's an insulated conditioned space. Also, your plumbing fixtures and your electrical conduits, as they come in through the attic space or through the floor joists, putting some spray foam around its air sealing is really important. Making sure that no air is coming in. 40% of your energy losses are actually not your insulation, it's your air seepage is coming through all the different joints of your house. A home energy audit will show you that. They typically do a blower door test where they seal off your house, they run some little smoke channels, and they kind of watch where the smoke goes. They put negative pressure on your house, suck out all the air, and not all the air, they suck out the air, and watch the smoke kind of flow. And you can see where it comes through. And it's mostly at the gaps between windows and doors, where your outlets are, your plug outlets. There's cheap ways to insulate those with a little foam pad. Your plumbing conduit, like I said, like here, if you don't really seal that up, air is just kind of coming right through that. Cold air is coming from your basement, right into that from your crawl space. We don't always have the opportunity to open up a wall, but if you do, that's great. You can use a spray foam. This is open cell spray foam. This is isonine. It seals all those little air gaps. So it fills up that space completely. Can be done very quickly. Dries within like 4 hours. It does have some off-gassing issues. It's definitely better used when you're doing an addition or a remodel or actually a new house. But if you don't have the opportunity to open a wall up, you can use other materials. You can open up just a small hole in a wall after you see where your insulation gaps are. Fill it full of blown-in cellulose, which is essentially recycled newspapers and boring mixed together. And fill that up. Or there's Johnson Anvil makes a formaldehyde-free spider insulation that they also kind of fill up that cavity and fill all 6 sides of that cavity to really get a good air seal. So it's really important to one, block air, and two, have insulated spaces. Again, should be common sense, but you'd be so surprised. Most homes built in this area, especially post-war, have almost no insulation, and there's simple things that we can do to really extend their life. Pop off the trim around your windows and doors. Put in some caulk and seal that space in there. Some expanded caulk. That's where a lot of your air loss is happening. Obviously, windows and doors are expensive to replace. They are, if you have single pane aluminum, old sliding windows, whatever. It's so important if you can afford it to replace those. If not, try to stop air getting in wherever you can. This will have an immediate effect on your heating and cooling modes. Floor joists, again, if you can insulate this, whatever's touching your floor or your cavity, if you can insulate it from the outside, the more the better. You can really not have too much insulation. I'm only providing actually one link on this, but this is the people here are in the back. This Energy Upgrade California. I didn't know they were here, so I'm kind of plugging people that are actually already here. But this is a great website where you can type in your county. It'll give you all the rebates and ways that you can get paid to do this energy upgrades of your house. And it's important because we waste so much energy. Again, when you're looking here, a third of it is to heat your home and heat or cool your home. Well, no, heat and cool is more than a third. Air conditioning is 11% there. So just that alone is really making a dramatic difference if you insulate those spaces. The rest of the residential energy uses, there's definitely ways to fix that too. Refrigeration is a big one. If your refrigerator is more than 10 years old, it needs to be replaced. There are way more efficient refrigeration technologies that we use today. Your electronics, and we are a gadget-friendly people here in the Bay Area. This is U.S. average. I would say we're probably more electronics here. We combine the other into electronics, and so let's say a quarter of your power is just your electronics. Well, what does that affect? How do you mitigate that? One way is vampire power. That when you're not having them plugged in, when you're not using your computer, they're still plugged in. It's still sucking power. It is still sucking power, and those little bits of juice really add up. Just looking at this, even a radio is a couple bucks a year. It's just plugged in. Your plasma TV, you're looking at a few $100s a year. By just having plasma TVs are horrible, by the way. They're the same as refrigerators. But anything plugged into the wall, is just still sucking power, right? And every little bit, like we've been talking about, we don't have the energy resources to go forward like this. So, what do you do? Well, there's lots of little gadgets you can use, and power strips that have remote sensors to turn off and timers. But any power strip will do. It's so easy to plug in. Most people have their computers plugged into power strips anyway. When you leave the room, turn it off. Shut it down, turn it off. It'll stop that power from being sucked out. This is a simple everyday solution. I know you probably all know that we need to save power, but people just don't do it as much as we can. So again, energy efficiency, we need to insulate as much as we can. You really can't have too much of it. You need to seal your house. Try to stop air infiltration. It's a really big deal. So seal between the garage and the rest of the house. Try to close the gap between under-insulated spaces that are on windows and doors. They never get filled full insulation, rarely do. Reduce your vampire power. Again, save over $200 a year, no problem. And replace appliances. If they're old, if you have an extra, if you have an old fridge, it's in the garage and it's just keeping some beer in it, no, it's wasting so much power. I know you don't want to get rid of it because it's a nice beer fridge, but get a new beer fridge. Healthy indoors. Indoor air quality is so important. Make sure your building is adequately ventilated. It's important to have a tight building, but unfortunately, in HVAC, there's the little V that no one really thinks about. It's ventilation. You got to make sure a house is ventilated, and it's not just heating and cooling HVAC. There's the ventilation there. It's in the middle for a reason. So you got to make sure you have a fresh air intake, but you have to make sure your building is tight and it's a good balance. Again, a good architect qualified designer or a qualified builder will help you along that. Recognize sources of chemical contaminants. So just keep the stuff out of your house, or don't buy it in the first place. Cleaners, paints. There's no need to have these VOCs in our house. When you see something that says low VOC, what's low VOC? It's still VOC. There's still organic compounds in it. It needs to be no VOC. There are plenty of good solutions out there that are not toxic. Carbon monoxide detectors, that's the law now, so it's all good. Always a good idea to follow the law, I guess. Durability. Again, don't think that green building has to be a new building. The best thing you can do is to extend the life of an old building. I love doing remodels. For 10 years, that's primarily what I did. And I worked with clients with no money. And I love it. It was so much more of a challenge. You get to really know a building, you get to know a structure, and you have the opportunity to breathe new life into something. Buildings should last 1,000 years. We've done our buildings the last 10 years. Most of my job now is litigation cases where the buildings are failing within those first 10 years, so the lawyers came in and sued everybody. And I'm here to fix it. But buildings should not last 10 years, they should last 100 years. You should be able to pass a house down to your children. That was the idea. Right? You bought a house, you paid it off, you passed it down to generations. We don't do that anymore. We just looking at the return on investment on that short-term goal. The builders are not interested in that life of the house. They're not invested into it, but homeowners need to be. And we don't have the resources, the energy resources, to really start afresh. We have a lot of existing housing stock that needs to be done right. If you are building new, then do it right the first time. Again, this is easy stuff that it's not, I'm not throwing big technology at these houses. I'm just trying to make them better, smarter, more efficient. Upkeep, maintenance is very important. Rain screen siding, again, is a no-brainer. It's pretty easy to do. And it doesn't change anything. It just adds the cost of some furring strips and a little bit of screen at the top and bottom. And sustainable design, again, it's not about just doing less damage. It's not just trying to achieve points on a lead sheet. It's about really changing our perspective about how we interface with the planet, how we understand ourselves as part of nature. Not as part of nature, as nature. We are nature. So the goal is not to make just efficient buildings, but it's to find out how to sustain life and encourage biodiversity. How do you make your life more biodiverse through the buildings that we exist within, or through the way that we exist within our societies. Sustainable design is more than just these solar panels and little gadgets and screwy light bulbs. It's really a way to think and a way to live, and we need to really change that. So I kind of want to show you some work that examples of this. This is a house I did. This was finished, I guess, a year and a half ago in Palo Alto, not far from here. This is a typical ranch house in Palo Alto that the owners had actually cut off the edge of the roof and built a tree house with it. They thought they were going to make this remodel happen a lot faster than they did. But basically, they liked the look of the house. They didn't like the color, but they liked this board and batten old barn look. But it was horribly insulated. They had a family of three kids in a 3-bedroom, one bath house. They were all 5 people sharing one bathroom. She was working I guess they're both lawyers. She was working out of her garage, an uninsulated, horrible cold space, heaters everywhere. So what we did is we took this house and we decided, well, what? All you really need is an extra bedroom, maybe a place to work. Not really doing a major remodel. But we actually took that and made this out of it. For not a lot of money, surprisingly. That back window here, this is a kitchen window right here. This window is the same window, we kept that. All I really did was added some wings to the side of the house. Added a master bedroom wing, added a little work wing for her. Extended the roof line out. But in doing so, we let clear story windows come in. So now you have light, the natural light that comes deep into the room. She has natural light to work with in our workspace on the far side. You know, and they have a connection to the outdoors, where right now they had a big grassy field. They still wanted grass, but they had, you know, behind this photo, they're kind of standing in the vegetable beds. But you know, they encouraged them to now live more indoor-outdoor experience and have more natural light. This was the front of the house. It was totally dark. You couldn't see in at all in the winter. We cut off the roof off the top of the porch there that was blocking all that light, and just flipped it up. Right? Now that the winter light gets deep into the house. The summer light's blocked out by a trellis, which a year and a half ago this is all grown in flowers now. But you know, it completely changed the dynamic of the house. When you can see the garage is the same. You know, here there's a garage there. Here there's a garage there. We kept the same wood, just took off the brick. You know, so you can do a lot with a little, but maintaining a house and just changing the look. The underside of this porch here, this really nice wood. This was a ceiling that was on the inside of the house that we had to take out from renovation, and you can see that here. This was their kitchen before and after. They had this really beautiful wood ceiling that extends in to the living room, and they couldn't afford to replace that wood ceiling throughout. It was a beautifully redwood ceiling. So what we did is we found a new material that matched that redwood ceiling. I got old construction sheets of plywood that were laying around on the job site that were weather grade, outdoor grade plywood. Stained it and then put some rusted steel right on there, right on the top of the wood, and sealed that. So this was kind of junk that we sealed with seawater right in their backyard. We rusted with seawater. And extended the house. And you see, like this is the existing house over here. You can see the wood ceiling, and we kind of mimic that with a different material, but the look is the same. Here it is in the outdoor, encouraging them to be part of nature, encouraging them to work with their existing house, but be really engaged in their site. And again, these are other clients that actually love it. So I think that's it. But I welcome any questions. Thank you so much for listening to the presentation. Thanks for being here.
Never go out.
ahead.
How much did it cost?
That house? Got guesses?
Yeah.
That house, I think the budget was just under $400,000. They don't own the house. They already had it, so they knew what they were getting into. It's not cheap. I'm not saying this is like a $40,000 whatever, but they're not remodeling the bathroom. Like they added a whole other bedroom wing, two more bathrooms. They added some significant space to their house.
You mentioned adequate ventilation in a current home. Can you say a little more about that? Because, like, for example, if I want to open the windows on a cold day like today, I'm letting the hot air out.
Right.
What kind
There are mechanical systems that you can add. Any heating contractor can direct you towards that. Basically, mechanical systems that will replace the interior air with fresh air from the outside and capture that heat loss. So you have a heat recovery unit that will take that heat from that you're losing from the outside as it goes out, and take the cold that goes in and look at the difference of that, and then kind of capture that energy back into either your hot water system or whatever. There's definitely ways to mitigate that. So there are mechanical, or there's on a cold day like today. I mean, granted, we don't get that cold in the Bay Area. It does get cold, but generally we're pretty lucky here.
Of course, I have a recirculating system where the warm air goes back up and into the...
Right, but it has an intake somewhere, and you can do an external intake, so it's actually pulling in fresh air.
Yeah, I noticed the color of this house that got remodeled now. Like here in California, where you have a lot of sun and so forth, I don't know if you like a dark color, which heats up, which has a potential heating up the house unnecessarily. But, so I was just wondering, is there a proper color choice on that?
It's not so much on your walls. The question is about color choice on walls, and darker colors do absorb more heat. And this client was a little freaked out when she came in. She's like, "I painted my home black. What are you doing?" But it's really not. The black is really undercover, under shade. And the roof is a really light colored roof. That really is where most of your heat gain is going to happen. So they couldn't, they actually have an asphalt shingle roof, on there, top shingle roof. And it's the lightest color we could find. It's a very, very light gray, and made from recycled materials and et cetera. And now when you look at that roof on Google Maps, it's the lightest thing in the neighborhood. It really stands out because it does not reflect the heat. Plus, there's solar panels, there's hot water, through also. Yeah.
Is Home Depot FSC?
Home Depot, I haven't been there in years. I was there last week for the first time. I was astonished by the amount of FSC that was all over the place. Yeah, they are now clearly labeled at Home Depot.
Home Depot sells 10% of all ends.
Sorry. There you go.
Regarding choosing a contractor, is there some kind of certification that you can get from contractors that say they're green building? I mean, because I could imagine that they say that they are, but from some other pictures that you showed, you can see some kind of scrupulous.
Right. Locally, Build a Green is a great certification system, the education and certification system. Not all contractors are the same, obviously, but there are definitely one. If you seek out the education, there is a lot available, especially in the Bay Area. Different municipalities have different organizations that work with them, like the Greenbelt Alliance, people that work with contractors and developers and whoever else to try to encourage these things. I would say, locally Build a Green is a great one that I've been certified through, which is a great education source.
Now, also, some of the pictures that you showed where they were holding the window together with duct tape, is there kind of list? Is there a list that you compile contractors' names that do that type of stuff?
But the thing about general contractors, they don't necessarily always know what their subs are doing. They'd like to, and they should, but the reality is not always that. So the subs are there working. They're all trying to get the cheapest price possible. Generally when I'm bidding a project and it comes out and there's 3 bids, I always, and the client said, I want to take the cheapest one. Don't ever take the cheapest one. There's a reason it's the cheapest one.
Is this working?
Maybe not.
My question has to do with ventilation and keeping the incoming air warm. Can that be done with pipes under the ground, essentially getting geothermal energy?
Definitely can, and if you have the land, it's an amazing way to do it. There is natural cooling techniques. If your house is on a hillside and you can bury the tubes, basically the ground is a constant 55-degree temperature. If you can keep that air and circulate it through those tubes, you can pull it into your house and have free air conditioning. Yes.
Do you have any experience with basements, how they work out?
Basements?
Yeah.
Besides leaking and drafting?
No, you dig your house up, you dig a big hole. How does that work out money-wise, energy-wise?
Again, you need to insulate your spaces. A lot of times people, they dig a basement, for the foundation. You're really doing it just to give a sturdy place for your house to be built upon. Typically people eventually, they want to move into that space.
That's the idea.
So that's the thing. You have to really be smart about it. You can waterproof a basement from the inside, waterproof that concrete, and insulate it. And kind of keep it, again, you waterproof the concrete, you can frame on the inside and then insulate that, but you have to make an insulated space.
But how does it work out economically?
Economically, is it good to build underground? No, it's expensive to dig dirt. But sometimes you do. It depends. Regionally, people do it. Not here, not so much. Okay, say just a couple more questions? 2 more questions?
Did you use low VOC paint on this building?
This building was completely done in YOLO color houses, 0 VOC, 98% food grade paint.
That's actually on the house right now. That's what we're using is YOLO.
Yeah, what I love about YOLO is they have like 16 colors. They don't have 16,000 colors.
Yeah.
It's like having a color consultant built into your house. It's great.
What's the longevity though? If you
I just loved it.
it breaks down quicker than some of the other paints, so that you have to use twice as much material between doing it twice as often.
Haven't found that at all. It depends on the material you're painting on. This is on fiber cement, and it absorbs it really easily and lasts a long time. As far as you can tell, Benjamin Moore actually just Benjamin Moore, Kelly Moore. One of the Moores just bought the distribution for YOLO, so it's pretty widely available now. One last one, I think we have.
What is the increase in square meters, square feet
Of this house?
Yes, and its impact
Their impact. Well, it's definitely smaller than most houses in the neighborhood. They, I think, added about 1,000 square feet, which is a chunk of a house. It's a good size. But they were living in a way, they had outgrown their space for a typical American household. This is still, I think, about 2,300 square feet total. It was about 800 before. No, it was about 1,300 before, and I guess they made about 2,300. So it's still now on that American average, which is probably low. Okay, thank you all. And now from the city, City of Mountain View.
Thanks. Thank you. All right, my name is Randy Suda, and I'm the Community Development Director for the City of Mountain View, and also resident of Mountain View. And we just wanted to leave you with a few things. First of all, we wanted to thank our speakers, Josiah and David, tonight. Thank you very much. I think it was extremely fitting that the coalition hosted and convened this event tonight, in that here in Mountain View, one of the things that our residents continuously say to us in public hearings and public meetings is their passion and concern for the environment and for sustainability issues. So it is perfectly appropriate that the coalition hosted this. In addition, we're quite proud of having companies like Google here in town that are putting sustainability in incorporating sustainability into their business practices and also into their construction practices. I just wanted to give you a very, very quick update on 3 things that the City of Mountain View is working on. First of all, next month we're going to be launching a program we call Energy Upgrade Mountain View. We've just secured funding from the federal government that will allow us to provide energy audits of 1,500 units here in the City of Mountain View. So it's a great start to our efforts to begin to retrofit our existing housing stock and housing units. If you have any questions on that program, Actera is at the table in the back, and they can answer all your questions. And that program should be launched around Earth Day, roughly April 22nd, so next month. The second quick update, as Maya mentioned, Tuesday night, the City Council adopted Mountain View's first green building ordinance. Our 2 of the planners that worked on that are sitting in the back, Noah Downing and Lindsay Hagan, if you guys want to wave. We're quite proud of them. They were able to tackle this very, very complicated process, worked its way through the council, worked with a great technical advisory group. A couple of the folks are here tonight. Forrest, Julie are here, and also we had 2 representatives from Google that helped us through that process. We're quite proud of the ordinance. It's a great first step. We know there's going to be a lot more to do in the future, but it's great to get our foot in the ground on this one. That will go into effect in the summer of this year after we're approved by the state. And lastly, a quick update. The city is going through the process of updating its general plan. So this is more of a long-term effort to define what that vision is going to be for the continued evolution, continued improvement of Mountain View for the next 20 years. Working on our second generation of land use and smart growth policies. As many of you know, our first generation was things like the crossings, Wisdom Station, where we converted underutilized industrial land into new residential neighborhoods clustered around transit stations. We're working on that second generation of smart growth policies, again, focusing along transit corridors along downtown. And importantly and fittingly for here, out in the core of the North Bayshore area in Mountain View, we brought in Bill McDonough to give us some inspiration, give us some ideas, and help us vision what North Bayshore can be in the future. And gave us that talk about it's not simply good enough to be less bad, but it's really essential to be truly good. So we're working on that through the general plan. We're in our EIR stage. much more work to do on that front, but we're very excited about the plan. I've had great support from the community. Over 2,500 attendees have participated through this process. And like Tuesday was a big night for our green building ordinance, Tuesday was also another big night from the standpoint of sort of kicking off the next generation of North Bay Shore, or North Bay Shore 2.0 as we call it. Working with our partner Google, the city and Google were able to enter into another ground lease for 18.6 acres of land just east of where we're standing tonight. Another big piece of city-owned land. As you know, Google is absolutely committed to building to the highest levels of sustainability and green, and we're able to consummate that deal Tuesday night, and that's going to be kind of the cornerstone of what the next version of North Bay Shore is going to be, along with transitioning and revisioning this area into not just an office park, but a mixed-use area of office, employment, residential, entertainment, and services, along with a real sustainable linkage back to our downtown transit center. So with that, that's a little update from Mountain View. If you have any questions or want updates on the general plan, please go to our website, mountainview2030.com. You can sign up for updates. And with that, the shuttles are outside, Ellie, that's correct? So shuttles are waiting for you, and thank you all for coming.